Hola, welcome. I am live. Okay, let me just go live on Facebook as well. And we are getting ready for homework, math homework help. Turn the volume down. Hello, everyone. Thank you for joining me. I am, yes, so this is KOG Math Homework Help. Let me know if you can see everything, if it looks right, if it sounds right. This is me in the corner. I'm Latrell. I'm a math coach, and I like to help you and your kids with your math struggles. OG. And I'm super excited to do this homework help. I hope that you guys have questions that I can answer for you. I'm about to share this in my Facebook group. It's always like 5 steps before I can actually do anything. And if you have any questions, go ahead and leave your questions in the comment section of this video, so that I can answer for you, because I know it's getting to the end of the school year, and sorry, end of the semester for college students. But for the school year, it is getting close to test time. Usually, when it's getting close to December, which is on holiday breaks, teachers like to give out tests, and math tests are happening. So, if you or your kids need studying, if you got a packet, or if you got a project or an assignment that you need to do and you're a little bit confused on it and it's regarding algebra, you can go ahead and just put the question in the comment section of this video and I will answer it for you. Um, Sharing in my group. So I don't really have anyone who asked me questions for this week to review. So I may come up with a few things and share. And if not, then I will see you next week. But I know that you guys are struggling with something, and I just want to be available to help you out. Also, if you don't need any help, you can go ahead and share. You can go ahead and share this video to your friends, family, and send them a private message of the video. Um, I'm live for an hour, so take advantage. I said, take advantage. Did I just share on my page again? Or did I share? I don't even know what I did. Thanks for the heart. Hopefully, I have good connection. I'm gonna just share again real quick because I think that I shared this video twice in the same place. I was thinking that we can talk about a little bit more, about rational equations and expressions, mainly expressions because um, I just got into simplifying expressions last week, which was last Tuesday, and I didn't really get into like adding, multiplying rational expressions, which is super important as well, and not the easiest thing to do. Thanks for whoever hopped on. Not sure who that is. Kendia, thank you for hopping on. Please go ahead and share. I would definitely appreciate it. Is that time of the how much does it cost to receive help from you? Oh, okay. Well, I have different packages, and so we can talk about that after, or you can instant message me, and I'll get back to you after this is over. But glad that you're interested. And I have different packages and different services, so you can let me know what would be best help for you. Almost swallowed my gum. So just send me a quick message, and we can talk about that. Do you have any questions right now, Kindia? Who's that? Josh Caver. Hey, what's up? What's up, my old bus driver? You can go ahead and share if you are able to. Appreciate it. Um, Send some people my way who need some help, and that would be very helpful for somebody, I'm sure. What am I trying to do? I feel like I'm supposed to be doing something. Maybe I just need to get started with some rational expressions, adding rational expressions. Remember, your questions are priority. What I have to do, what's on my agenda, is secondary. So if you have any questions, I would definitely go with yours first. So just drop them below. So with adding rational expressions, it's very similar to adding fractions, and it actually is adding fractions actually. So um, is remember the rules of adding fractions, and if you are a little um, shaky on adding, subtract, like just operations on fractions, period, you can hey, Mr. Polanski. Mr. Polanski was my sixth grade teacher. Pretty awesome. He has long hair right now. He didn't have that long hair when he was teaching me. But Mr. Polanski is awesome. So cool. What I was saying about rational expressions. Yeah. So a rational ratio. Let's get into it. Looks and looks like this. 1/4 as well. So a ratio is a fraction. It's basically saying one for every four, or one out of four. You can this one. You've heard it that way. Um, and there are other ways to say it. 1/4. Like let's say, uh, one student to every 4 computers. That's that sounds like a good situation. You don't have students fighting over computers or computers. That is a ratio. A fraction is a ratio. A fraction is a type of ratio. So so when you hear fractions, it's talking about fractions. That's what it's talking about. Um, and here's an example. Subtire. Here's an example of a rational expression. Then we got u minus v 8v plus u minus over v. That's an example of rational expression. Um, Once again, an expression is just terms. It doesn't have an equal sign, so it doesn't equal anything. It's just some stuff on one side of the equation, and you're simplifying using different properties and things like that in the order of operations and whatnot. So um, let's look at first how to simplify an actual fraction or a fractional expression. So we can look at, I was just doing fractions with my students today. Minus 2/4. Yay, easy. So what we want to do is we want to make sure that the denominator is the same for each fraction before we combine the fractions. Because if we think about it, the pieces of a whole, get them pretty even. Okay, hopefully that's as even as it's going to get. But this 3/4 represents three 4 pieces. And this 2/4, so we can two. Oops, it's just shading two. Just getting ahead of myself. So if we are taking 2 away from the 3 that we already have, we're doing 2 of those fourths. A fourth is a thing. Each one of the pieces is a fourth. A fourth is a thing. If we're taking 2 away from the fourths, 2/4 away from the 3/4, then that means we are crossing out, and we're just left with 1 of the fourths that we had. We had 3, we took 2 away, and we're left with 1. So the answer is cool. Hello, Mitch. Hello, Miss Corrine. Haven't seen you in a while. And so if you look at the math that we just did, we basically, so we did 3 minus 2. 3 minus 2 is 1. So we're left with 1/4. And when the picture or the diagram that we have. So when we are going back to this expression over here, our denominators are the same. We're not touching the denominators. We're going to, and what we can do is just write the everything in the numerator. So we got u minus v plus minus 3v. And I'm going to put these got minus. And if it's minus, then that means that you have to distribute the negative. Okay. So since it's not subtraction, and you can distribute positive to each one of the terms, we don't need the parentheses. So we can just say u minus v, xv minus 3v. Oh, it's actually u. 6. I'll be in the same problem. Easy to get them confused. Okay, so now what we're going to do is combine like terms. I just sent out a math formations KOG math formations email, and if anybody is interested in signing up for it, I have 6 already prepared, and thinking about taking a break from it, but the 6 that I have already are packed with knowledge, advice, tips, helpful information. And the one I sent out today said, I am collecting math skills. What does it say? Oh, it says, I'm always collecting new math skills with each lesson. So, yeah, with each lesson, you're going to learn something new. But the idea is, or the question is, what are you going to do with that information you're learning? Because math builds on itself. Like what you learned yesterday, you're going to use today. What you learned today, you're going to use tomorrow. So that's why it's important to take notes so that you can retain that information. Even if it's not in your brain right now, it's in your notes. And then you can go back to your notes, review your notes, and use your notes to help you with what you're doing later, and hopefully it'll get in your brain because you're using it, and hopefully you're studying it. It's good to study your notes like the same day. Can't say that I did that every time, but that's the rule of thumb. And if you rewrite your notes, also rewriting them in your own words so that they make sense to you. And then if it doesn't make sense, you go and ask your instructor, okay, this doesn't make sense. What does it mean? Can you help me again? Can you go over this again? And come ask me. May be able to help you. So if you're interested in KOG math formations, put that in the comments of this video, and I'll sign you up for it. I'll just need your email and stuff. But anyway, I brought that up because in this expressions in this rational expressions problem, we use so many basic skills already. Okay, so we had to know that the denominator has to be the same in order to add the fractions. If they're not the same, then we can't do anything. We can't add anything yet. So we had to know that the denominator has to be the same in order to add. We had to know that now we need to know that we can combine like terms using whatever the variables are. And I got v and u. I'm changing these. I'm going to this step because they look this. I'm writing them to look the same, and I don't like that. I'm changing to a and b. All right. So u. I'm gonna write this equals a. I don't need minus b plus 6b minus 3a 8b. All right. Which one? My big Spee is trying to solve this problem for us. Okay, so we're going to combine like terms. That's a basic skill that you need to put in your toolbox and remember for later. In order to combine like terms, we want to look at what variables are the same. So we got a and we got negative 3a. A, it has a coefficient of 1. That math that I was talking about last time. And we want to combine them. So let's then our B's we want to put together. B, B, B. all over. Okay, so let's do this subtraction with a. 1a minus 3a is going to give us negative b. And then negative b plus 6 is negative 1b. Negative b plus 6 is the same as 6 minus 1. Pause. Negative 1b plus 6b is the same as 6b minus 1b, which is going to give us 5b. So it's positive, and it gives plus 5b all over 8b. Okay, and guess what? That's it. That's simplified. We had to identify that the denominators had to be the same in order to combine these fractions. They were. And we distributed the sign, which was addition, which doesn't change anything. Then we combined like terms and simplified. We used operations on integers. So that's another skill. All these skills, well, not all these skills, but fractions and integers are in my mini course. The top 5 concepts you must master in order to pass algebra. And if you are getting confused on some of these steps, then it'd be best if you enroll in that mini course. It's free. Okay, you will appreciate it. Let's do another. Just want to check my other screen to see if anybody is watching. And let's move on to another problem. I'm going to clear the screen. Let me get a sip of water. My computer is frozen. So let me try another type of fraction that in rational expressions. So in this situation is going to be where the denominators are not the same. And whenever I go over this with my student, he just hates it. He's like, oh, I don't want to do this. But when you get it, and that's the thing about life, like the hard thing that you need to do. When you get it, it's like, I am so glad I understand how to do this, because I remember when I just did not know how to do this. And I didn't even want to know. But now that after I worked on it, I had a one of my one of the members in my group, my Facebook group, KOG Math Achievers Club. She asked me about a problem. I just sent her explanation real quick, and I asked her how did it go, and she said I didn't get it at first, and then I tried and tried and tried, and then I understood it. And I was like, amazing, that's great. My computer shut down on me. So it's really important to just keep trying, keep on trying, and um, your brain will move around, and more electricity will start to produce in your brain, and which helps you to learn and helps your brain to grow so that you can understand it. You can understand what is going on. Okay, here's another one. um so I'm going to do one with the same denominator again. 1 minus excuse me. Okay, this is gonna be interesting. So our denominators are the same. That's important to note. So we can manipulating the numerator and where it is M3N. Okay. Um, so with the numerator, here's a different situation that we're coming with the numerator. We have this expression, this like mini expression minus this mini expression. So what's happening really is being multiplied to this last expression, and distribute. So that's called the distributive property to multiply this -1 expression. Um, I'm going to write this again. It's any um, signs being imposed on it, but the second one does. So -1 times -3n is going to be n, because a negative times a positive is a negative. That's a basic rule that is essential to getting the right answer. This is high level algebra, and a basic rule is showing up in a high level algebra question. I've seen students get questions like these wrong because they put positive instead of negative. That's like something that you're going to be like, oh my God, why did I make that mistake? Right? So you really need to, it'd be best if you solidify those basic skills. Take my course, my free mini course. It's just made up of skills that I've seen. It's made up of skills that I've seen over and over again students struggle with. And so it's not just something randomly chosen. Um, it's something that's really important that uh, a lot of students are struggling with, and you might be struggling with as well. Subtraction. So we want to combine like terms, and I see we have m's and we have n's. We together, keeping the sign. This m is positive. This m is negative. M. All right. So the next variable is n. Okay. And then disregard this. Then we have 6 times n. All right. Now let's actually do the combining. M minus m is 0. So there as a placeholder, so you know that that's what happened to the m's. And then -3n. Let's write a number line for you. When we subtract, right, this way, it doesn't matter where you start on the number line. Doesn't matter where you start. If you're subtracting, you're going that way. Try not to confuse your multiplication of negative numbers, multiplication and division rules of negative numbers with the addition and subtraction rules of negative numbers. It's really important that you separate them because they're not the same. They're not the same. And once again, this is in my free mini course. We're starting with -3, and so we got -3, -5, -6, -7. I'm gonna stop there. We're starting with negative, subtracting 3, -3. There it is, -6. Negative over 6m cubed n. All right. I'm gonna get rid of this. Actually, let me just write this up here. Questions on this subtraction that I just did, let me know. I got n over times n, and here's another situation. We've got a fraction. I want to separate the numbers from the variables. I could do that. Why? Because multiplication is happening between these two in the variable. The number is called the coefficient. The coefficient is a number that, or an integer that is being multiplied to a variable. When it's being multiplied to a variable, it's called a coefficient. I can separate the number from the coefficient. The number from the variable. I can separate this variables as well, and I can write it like this: over 6 times over mn. That is the same thing as what I have in the previous step. Why? Because the rule is for fractions where you're multiplying them, you multiply straight across the bottom. So if we multiply, excuse me, if we multiply these fractions together, they'll give us what we have in the previous step. Questions? Okay. So now all we need to do is identify how we can simplify. Identify how we can simplify. What I want to do is look at the number. Look at the numeral fraction. The numeral fraction says -6 divided by 6. Negative, well, first of all, 6 divided by 6 is 1. Divided by a positive is negative. Okay, cool. We have n in the numerator, m cubed n in the denominator. So there's an n down. And let's separate a little bit more. I still could have separated some more. In this numerator, there is a times 1. 1 times n is n. And you're going to see why I put that in the next step. I want to write n, and I want to write m right here. Once again, if we multiply these two fractions, 1 over m times n over n, then we're going to get n over, we're going to get 1 n over O. Same thing as what we have in the previous step. So let me erase this. A little bit more simplification, because n divided by n is 1. That's 1 too. So we times 1. Awesome sauce. Let's multiply this all together. 1 times anything is 1, right? Okay. And -1 times anything is, oh, sorry. 1 times anything is 1. 1 times anything is itself. So 1 over m cubed times 1 is 1 over m cubed. And -1 times anything is the negative of that thing. So -1 times 1 over m cubed is negative 1 over m cubed. And that's the answer for that mistake. Okay. I don't see any questions. And I appreciate everyone who jumped on. Let me check on my other screen. I don't know when I did that. My computer shut down, so I might not want to do that. Okay. Let me know if you have questions on this problem. I think I'm going to do one more where the denominator is not the same. Here's one. Okay. We get over one minus 5 over 4. Complicated. Does it looks innocent? Very simple. Simple looking, but let me tell you something. It's not. So it will be after we after you understand the my explanation. So here the denominators are not the same. And that's a problem that we're going to fix. So like I was saying before, when we had the minus the two, we're taking fourths because fourths are things, 1/4 are things, and we had three of those 1/4. We took two away from those 1/4. We took two 1/4 away from those 3/4, and we just had 1/4 left because 3 minus 2 is 1, right? Yes. So we were using the same size pieces. We were using the same size fractions. But in this situation, our denominators are not the same. We got 1/4. We got a fourth. It's 5 over x. It's 5x fourths. But we got fourths. And we got something else. X minus 1s. What's that? I'm not sure exactly what that size looks like because the variable is there and the variable can be anything, right? So what we have to do is make the denominator the same. We got to make it the same. If it's not the same, we got to force it. The same. And we got to find factors of the denominators in order to make the denominators be the same. When we have a fraction, when we're subtracting fractions that or adding fractions that have different denominators, let's say we had 3/8 minus 2/4. Not the same, right? Um, we can make them the same by to make it 8. Let's do that. 4 times what is 8? 4 times 2 is 8. But we also have to multiply the numerator by 2 to get a fraction that is proportional to, or that is equivalent to the original fraction, 2/4. So minus our new fraction is going to be 2 times 2 is 4, 2 is 8. Now our denominators are the same, and we can do subtraction. Just want to point out again, now we're working with eighths. Eighths are things. Eighths are a specific size of a piece of a whole thing that has 8 pieces. I'm not going to draw it out because that's a lot of pieces. But once again, eighths are things, and we're taking 4/8 away from 3/8. Okay, so let's say eighths are cookies. And um, Tahira has four cookies, and sorry, I don't think I want to say that. Let's here 4 cookies. Here are 3 cookies. Um, yeah, okay, so Tahira has 4 cookies, and Tahira, I'm trying to think of another name. Ethan has 3 cookies. Tahira, Tahira's mom told her to take Ethan's cookies away because he was eating too many sweets, and um, also to take away one more, to take 4 cookies away. So he has 3 cookies and take away another one too. The next one that he's thinking about getting for tomorrow. So, okay, I had to think of this real quick. So, Tahira took away Ethan's 3 and 1 more. So 3 plus 1 is 4. So he has, how many cookies does uh Ethan have left? Ethan have left. Ethan one has -1 cookies because he got his 3 that he has in his hand taken away. Also, he got that one that he was going to have tomorrow taken away too. She trying to stop him from eating so much sugar, which we all need to work on doing. So that's what this uh, subtraction. Um, that's the story for that subtraction problem. Now let's use this same situation, this multiplying, making the denominators the same in this rational expression. So we want the denominators to be the same, and we need to basically multiply the denominators together in this situation. So we're going to multiply x minus 1 times 4. X minus 1 times 4. So the denominators have the same thing. Um, the denominators are basically a combination of both denominators. The one denominator is a combination of both denominators because they're both factors of each other now. And we're going to manipulate the numerators so that they resemble and they reflect the manipulation that we did to the denominator. So 6 was up here. How do we make this start over? Um, so we got over 4. All right. So we're saying we're starting over. I skipped a lot. Um, we can. Oh, I should have did another type of problem. Hi, Carmen. Hey, girl. Um, same. I said that like a million times already. X minus 1 and 4 are not factors. 4 was a factor of 8, so all we needed to do was multiply by 2 in order to get 8, and that's what we did. But x minus 1 and 4 don't have anything in common, so we're just going to multiply them together to get that that factor that both of them have in common, which will be them multiplied together. So we're going to multiply the bottom by 4, and then we're over here this one, just like we did over here, top and bottom. Got to balance it out. And the direction, the denominator is going to be 4 times the numerator for this fraction is going to be 5, and the denominator is going. The denominators are the same. Now all we need to do is subtract the numerators. And we got 24 minus 10. Cool. Okay. So can we simplify? Hmm. No, we can't. And the reason we can't cancel anything out is because neither of these terms in the numerator. So this is a term, and both have a common factor that is in the denominator. So we can't simplify. We can't cancel anything out, and that is the final answer. Now, let me problem that is a fractional problem that is similar to what we just did here, because the one I did before it didn't exactly mimic what we did here. So let's see, a fraction could be 3 minus let me use a bigger 7 minus 2/8. Okay, now here neither of the denominator 7 or 8 are factors of each other. Neither of them are factors of each other. We could list out the factors. Sorry, we can list out the multiples. That's what I meant to say. Multiples or factors. Um, we can list out their multiples and find out what they have in common. Least common multiples, LCM. And that's what we want to find, the least common multiple that between 7 and 8. So we got 7, 14, uh, 4, 9. I'm telling you, 56 is the one. 8, 24. So that's 3, 4. These 8 times 5 is 8 times 6. Do they have 50 a common factor, but do they have any less? Remember, it's least common multiple. No. So our new denominator is going to be 56. And this is what we did here. When we multiplied, when we kept the denominator and multiplied it by what the other one was, minus. So in order to make the denominator 56, we have to multiply the by the other denominator, which was 8. And we need to multiply 8 and 2 by 7. And now is 56. 5 times 8. Hey, anybody jumping on? Appreciate it. Share, please. 5 times 8 is 40 and is 14. There you go. So that is basically what we did with the question over here. 40 minus 14, or 40 minus 10 is 30, and 30 minus 4 is 26. So, or 56 is 40 56 minus 14 56. And let's see, they're definitely even. I know that 26 is 13 times 2, but 13 is a factor of 56 because I know there's 13 of each suit in the deck of playing cards. And how many cards are there altogether? Isn't it 54? 50 something. But we find out. So let's divide by 2. 26 is 13. And 56 divided by 2 is 28. We can't reduce anymore. Yeah. So 13 and 28 don't have any. Hello, Mitchell. Hello, Benito. Thank you for jumping on. Please share this and this for this fractional expression. All right, I'm going to stop here. And I appreciate anybody who jumped on, who shared, um, and ever asked me a question in the past. Thank you. And I'm going to get back to you, Kendia, about possibly working together. Appreciate you for reaching out. So I would just want to wish everyone a good night, and don't forget to take advantage of my free mini course. I don't know how long that's going to be free, honestly, and because it's like super duper valuable. Put a lot of work into it, and working on moving into other higher levels, like a membership where I go live and help people who really do need help. Like, can't wait for me to go live so they can ask their question. Um, so, working on some things. And if you would like to be a part of that, if you know someone who would like to be a part of that, please send them my way. And once again, you can sign up for the free course, free mini course for your basic maths, for strengthening your basic math skills. And if you have a question that you need answered or a concept that you need explained, you can submit your question to the Ask Me Quick lesson, and I'll send you a video tutorial, a copy of my notes. So basically, this type of video, you'll have a screenshot of my notes that of each step, and extra customized study material. Isn't that awesome? Especially since it's finals time. I know when it was finals time for me, I was like, oh my goodness, I gotta remember all these things and I don't really get it. Somebody please help me. So reach out to me, and take advantage of my resources and services that I have available. All right, everyone. Have a great evening. Appreciate you. And I'm glad I'm able to do this to help you out. All right, I'm going out. Deuces.